Hello, let's take a look at these chemical equilibrium questions. This multiple choice question reads, a reaction reaches equilibrium in a closed container according to the following balanced equation. Which one of the following changes will increase the value of the equilibrium constant? Equilibrium constant is Kc. Now, the only thing that affects Kc is temperature. So we can eliminate A and we can eliminate D. Next, remember Kc is equal to the concentration of products divided by the concentration of reactants. Now, if we want to increase Kc, we should try to increase the concentration of products. That's going to increase the numerator and that's going to increase the Kc value. Let's see how we can do that. We can see that the forward reaction is exothermic. So forward is exothermic. How can we favor the forward reaction? We can favor exothermic reaction by decreasing temperature. Remember, if you decrease the temp, it favors exothermic. Let's see if that's an option. We have cooling the container. So the answer is C. Remember, if we cool the container, if we decrease the temperature, the system will want to increase the temperature by favoring the exothermic reaction, which is the forward reaction. That means the amount of NH3 would increase, therefore the equilibrium constant Kc would increase as well. Okay? Let's move on. Question number 6. Pure hydrogen iodide gas, HI, of concentration 1 mole per dm cubed is sealed in a 500 cm cubed container at temperature T. The reaction reaches equilibrium. They give us the equation. Again, we leave out definitions and we jump to question 6.2. The graph below shows how the concentration of the reactants and products vary with time. Which one of the curves, X or Y, represents the change in concentration of products? Okay, so remember, at the start of any reaction, we have no products. So the concentration of products would be 0. So which curve starts from 0? This curve, X. So the answer to 6.2.1 is X. 6.2.2, how does the rate of the forward reaction compare to the rate of the reverse reaction at T equals 4? Choose from higher than, lower than, or equal to. Now, you would be tempted to say equal to because you are seeing that, okay, time is the same, concentration is the same, and so on. But we need to remember that at the beginning of any reaction, right, before equilibrium is reached, we have a lot of reactants and very little products. So the reactants are going to be colliding much more. And so the rate of the forward reaction is going to be much higher than the rate of the reverse reaction before equilibrium is reached. So they want to know, how does the forward reaction compare to the reverse reaction? The forward reaction is going to have a higher rate. Okay, that's because at the beginning, again, we have a lot of reactants and not so many products, or not so much products. Question 6.3. The equilibrium constant Kc for the reaction at 0,04 or is 0,04 at temperature T. Calculate the number of moles of iodine present at time equals 6 seconds. So in other words, at equilibrium. We see the mark scheme, 9 marks, usually means we need to do our rise table. So let's go to the rise table. So we write out our reaction, 2HI goes to H2 plus I2. Now let's construct it. So RICE, put a line like this. Now R stands for ratio. What is the ratio of these compounds? The ratio is 2 to 1 to 1. Okay? Let's just neaten this up a bit. Okay. I stands for initial. At the start, how much did we have of everything? So at the start, they tell us that we have 1 mole per dm cubed of HI. So at the start, we have 1. Okay? So, and at the start, we'll have no products. So we'll have 0 here and 0 here. Then C stands for change. How much did it change by? They didn't tell us anything about the amount of change, nor did they tell us the amount at equilibrium. So in this case, we'll have to use X, right? Now, since products are being formed, we're going to say plus X. And since the ratio is 1 to 1, this is also going to be plus X. Now, since the ratio here is 1 to 2, the amount of HI that is used is going to be minus 2X. Okay? Remember, reactants are used up, so they get a minus. Products are formed, so they will get a plus. Now we can work out the amount at equilibrium. The amount at equilibrium for HI is going to be the amount that you started with minus the amount that is used up. So that's going to be 1 minus 2X. Then for H2, it's going to be 0 plus X, which is X. Then for I2, it's going to be 0 plus X, which is X. Now this represents the concentration at equilibrium. Now we can work out Kc. So Kc is going to equal the concentration of products. So that's I2 to the power of 1. Then H2 to the power of 1. Then I2 to the power of 1 divided by Hi to the power of 2. Now we can substitute. We know the Kc is 0,04. That's equal to H2, we know, is X. So X to the power of 1 is X. Then multiplied by I2 is also X. And divided by Hi is 1 minus 2X. And that is to the power of 2. And now we can solve for X. Obviously, we may need to simplify a bit. We can use a calculator and use the solve function on the calculator. Right? But whichever way you choose, we can then solve for X. X is then equal to 0,143 moles per dm cubed. That represents the amount or the concentration of H2 and I2 at equilibrium. Now, the question is asking, calculate the number of moles of iodine. All right, so at equilibrium for iodine, we know the concentration, 0,143 moles per dm cubed. Then they tell us the volume of the container at the beginning. The volume of the container is 0,5. So volume is 0,5 dm cubed. Now we can calculate the number of moles. Number of moles equals C times V, 0,143 multiplied by 0,5, and then we can solve. That is equal to 0,072 moles of iodine at equilibrium. Okay, let's move on. Question 6.4. The graph below shows how the rates of the forward and reverse reaction change with time. The temperature of the container was increased at T equals 10 minutes. Which reaction shows an increase in rate at T equals 10? Choose from forward, reverse, or both. Okay, now let's look at this. So the rates were here. Now the rates are there. So this was the equilibrium before the change, and this is after the change. So we can see that the rates both rates have increased. So the answer to this is both have increased. Next, 6.4.2 is the heat of reaction delta H. For this reaction, positive or negative? Fully explain the answer. Okay. So they tell us that the temperature was increased. So if the temperature was increased, that means an endothermic reaction is favored. Right? Now, if we look at our graph, we can see that the forward increased more than the reverse. Right? We can see it here. So the forward is a solid line, so it increased all the way up there and then reached equilibrium. but the reverse just went here. So that tells us that the forward was favored. Okay, now since the forward was favored, we can then make the statement that the forward must then be an endothermic. That means the forward reaction has a delta H that is greater than 0. Okay, that's it for this question. I hope you found it useful. If you did, please leave a like, share, subscribe, click that bell icon, and if there's something specific you'd like me to answer, let me know in the comment section below. Until the next one, bye bye.